Hello everyone. So we are going to start a new unit. It is called logarithms. And in this unit, we will talk about what logarithms are for, the functions, the equations, and basically anything that we need to know about logarithms so that we can use that for specific applications. Okay, first a little quick history, and you can actually find this anywhere. It started in around 1614 officially in terms of the laws and rules, but it goes back a few hundred years initially. John Napier was the first person who brought this up, and the whole concept of logarithm was to ease the computation. That's what it was. Instead of having repeated multiplications, basically John Napier looked at it as basically an extension of exponent laws and then applied. And then later, Leonard Euler made the connection between the exponential functions and the logarithmic functions, and it turns out that he proved that they are inverse of each other. All right, now notation and definition. So the notation first, very important notation, which is the way it's written, logarithms, the short abbreviation log, that is the short abbreviation for the logarithmic expression. So the way we will read that is we say log of x base b equals y. And what it means is basically that y is the exponent. And here it is. That's the y, that's the exponent. So base to the exponent will give you the argument x for log. And that's what that means. Basically, these two, the exponential form and the logarithmic form, they're interchangeable. And there are some restrictions. We have to make sure that we follow that. So b has to be greater than 0. The base can't be negative. And also x, the argument of log, cannot be negative or 0 for both. And by convention, since our number system is based on powers of 10, we say that any base 10 will be called a common log. Okay, common logarithms. And we usually don't write base 10. It is implied. So if I have a setup like this, log of x equal to y, that is saying that log of x base 10 equals y, but we don't write the 10. We just leave it alone. By default, it is 10. Anything else, we need to write it down. Okay, let's go through and let's do some evaluation. So first, remember that the value of log expression, that's the exponent. So here, the first example right here, example A, let's start with example A. We're saying that 2 to what exponent equals to 4. And we don't know what the exponent is. So 2 to the exponent equals to 4. Excellent. So the way we write the question mark, obviously, this is primitive. Let's call it x. All right. So we can say now 2 to the x equals to 4. And in this case, we know x equals to 2. Great. And that applies to every single one of these. Okay. Let's go ahead and finish all of them. So basically, 3 to what exponent equals to 243. We are just changing the format from log to exponential. Okay. In here, 2 to what exponent is 0.25. Now remember, this is written in a decimal expansion, but you change it to a fraction and go from there. Here, how would you write this down? Remember, we don't have a base here, but the base is by default 10. So we say 10 to what exponent equals to 10 squared. Well, that is very easy because you know that is x equals to 2. Obvious. All right, so you go through it and then let's find out what the answers are. Okay, so for B, 3 to the power of 5 is 243. For C, a quarter, 0.25 right here, that's equal to 1/4. Okay, so this piece right here is 1/4. I can write it as a fraction. So x to the power of -2, I will give you a quarter. Exponent laws, very important here. You need to know your exponent laws inside out, okay? And here we already talked about that, x equals to 2. Great. So let's continue. Let's change this to exponential form and vice versa. So in this case, we have a part A, we have the logarithmic form. Let's change that to the exponential form. That is basically, you go through it, 2 to the 3 equals to 8, and that is true. Here, we are going to go back. That means we're going to change the exponential form into logarithmic form. So first, you put the log. That's the first thing you do. Okay? Next, the 3 exponent, that becomes the value. The 10, the base, that's the base of the log, and the 1000 becomes the argument of the log. So that is your 1000. And that is basically it. Okay, and the part C, so basically we're going to go through that again. So log base 4, okay, 116 becomes the argument, and -2 becomes the value. So 1/16, that makes sense because we can rewrite it as log of 4 to the power of -2, or the exponent -2, base 4, that is equal to -2. And notice that whenever you have a setup like this, where the argument and the base, they're the same, then the answer to the log is the exponent of the argument of the log. Okay, and last one, what is log of 8 base 8? That means 8 to what power is 8? Well, we know that. That's very easy. That is 1. And it turns out that any log argument based with the base of the same will always give you 1. That's the next couple of rules. I'm going to write it up for you. Okay, let's do a few summaries. The first one, very easy one. Log of b base b is equal to 1. Simple as that. That's the very fundamental first rule of log. Excellent. Next one, if we have a setup like this, log of b to the x base b, well, we know b to what exponent is b to the x? Well, in this case will be x. Great, that's another one. But now we can incorporate both of these two, the rule number 1 and rule number 2 together. And basically what we can say is that if log of b base b is 1, then this expression can be also written as x log of b base b equals to log of b to the x base b. Okay, so these two expressions are exactly the same. What you're doing, basically, you're bringing the x to the front, and that becomes the coefficient of the log term. You can do that. That's one of the laws. Another extension of log number 2, or law number 2, is this one right here, where b to the power of log of x base b is equal to the argument of the log. As long as you have these two bases the same, then the log of x base b as exponent gets simplified to become only x, all right, when it's raised to that power. All right, so that's another one. The last one for this series is that if we have is extension of rule number 1, log of base b of b, or log of b base b equals to 1. And another way of writing that is that if I write it as a ratio, log of b divided by log of b, so these two b's, one was the base, the other one was the argument, I can write it as a fraction. That is equal to 1 because log of b divided by log of b is 1. So based on that, you can actually say that log of b base b equals to log of b divided by log of b. Now in this case, b is the base here, but we can change the new base to anything we want. Let's call that m. All right, so that is the number 3 rule. Okay, so you can, it's called the change of the base rule, that you can do that as long as both bases are the same. You can write it as a fraction. Okay,